Test students, employees at FTI, Wipro, IASC, KEC, Enametal, Lab India, AUME, Biocon, DSA, Microlab, Noggle, and Armstrong, etc. Mr. Shagar has coordinated and conducted many seminars, workshops in various subjects under the banner of IIPE. He had participated and presented papers in many number of national and international seminars also. He has trained more than 20,000 persons in various disciplines. Lean tools like TPM, 5S, VSM, setup reduction, safety, maintenance management, etc. Quality core tools like SPC, FMEA, APOP, PPAP, MSA, and problem-solving techniques like RCA, 5D, WW, etc. He has facilitated more than 100 lean quality projects like at KL and other companies successfully. Created a WCM, that is world-class manufacturing setup for N-mill manufacturing in Enametal. Now over to Mr. Shekhar.
Thank you, Mr. Vegan. Thank you very much for the nice introduction. Thank you very much. Good evening, everyone. Right away, I'll start sharing my good.
You can switch on your camera also, sir.
No, camera is not working yet, unfortunately. Something is wrong with the other laptop. It is working, but the other laptop, it didn't open. This password did not open. Okay. Good evening, ladies and gentlemen who are attending this technical session on OEE. I welcome you all for this evening session, and thank you all for attending this during this evening time of Saturday weekend. Okay. Now, today's subject is improving equipment effectiveness through OEE measurement. What is OEE? Overall equipment effectiveness. And this parameter is measured and used to improve the effectiveness of our resources, maybe equipment we can call. Before going to the next slide, see, this OEE is a function of three major divisions in the organization. One is maintenance, the other is production, and the other is quality. So before going to this OEE concept, we should also understand a little about maintenance and what are the parameters, metrics and all, and a little about production and a little about quality. So first we'll see maintenance. What is the main purpose of maintenance? In any organization or an industry, the main purpose of the maintenance function is to ensure maximum availability of any physical resources. We can call it as A. Then when the physical resource is available, then what you should do? You should ensure that the physical resource gives the rated output. We'll call it as S. What is this rated output? The rated output is the output which is envisaged when the machine was purchased. When we purchase, we tell, oh, this should be giving this much pieces in which this speeds and feeds and this quantity and all. So rated output as the specification of the machine, what the machine is supposed to give when we bought the machine. The third one is the physical resource should also give the rated quality. What is the quality levels you should achieve when you bought the machine and when we purchased the machine. So the maintenance function has got main thing is it should avail the equipment or the physical resource should be available. It should give the rated output. Then it should give the rated quality. Two more aspects are very important other than this availability, output and quality. The fourth one is all the safety aspects related to the physical asset should be in place, both physically and functionally. This is a very important point because I have seen during my service, I have seen so many machines will be running without guards. It will give rated output, rated quality, and the machine will be available. And they will tell the machine is all running, sir, no problem. None of the guards will be available. None of the limit switches, safety switches, safety guards have been bypassed. So that should not be the case. While we are ensuring availability, output, and quality, we should also ensure safety. All the safety aspects related to the physical asset should be in place, both physically and functionally. So many cases will be physically present, but functionally it will not be working. So it is very important. I only request the maintenance person to ensure this aspect. Next one is the equipment or the resource should consume optimum resource. For example, energy. We should consume the optimum energy while delivering the above results. When it is giving the rated output and the rated quality, it should also utilize, for example, power, the optimum power. So this is the basic function of the maintenance department. If this is ensured, the maintenance people can be happily be there. Nobody will bother them. Because you all know that maintenance fellows only will be bothered when the machines are down. They'll be free and they can do their job. Now, how this is done, how this objective is met? By doing various kinds of maintenance. We have got various types of maintenance. Most of you will be aware of it. We have got breakdown maintenance, we have got routine maintenance, preventive maintenance, predictive maintenance, corrective maintenance, condition monitoring, condition-based maintenance, reliability-centered maintenance, zero maintenance, remote control, TPM, and nowadays, which is coming into vogue, is the artificial intelligence, machine learning, and IoT. This is picking up a lot nowadays. Now most of the machines are having are requested with IoT-enabled machines. We'll not go into the details of these types of maintenance. We'll go to the next slide. Now, maintenance, we have told what it should do, what is the function. Then we have to measure whether we have done the function as per the requirement. What are the various metrics of maintenance? Because we are all planting, I thought I will dwell into this point. What are the various matrices we can have for the maintenance department? One matrix is the downtime percentage, which is very commonly used. What is the downtime percent? 1%, 2%, 5%, like that. Then, in any factory or industry, you will see that machines will be categorized into critical and non-critical machines. Critical machines are those machines which, if they are down, there will be a lot of production disruptions. Line may stop, machines may, a lot of other machines will be idle, all those things. So those critical machines, uptime as a percentage should be monitored. Then one other most important thing is MTBF, mean time between failures of critical machines. This is told in number of hours. Similarly, MTTR, mean time to repair, is also for critical machines. It is also expressed in terms of hours. Then the financial thing is budgeted expense to actual expense. This is very important. The top man will be very much interested in this budgeted expense to actual expense. Then overtime versus regular time as a percentage is utilization of manpower. Then PM plan to completed percent. This is our system, how disciplined you are in carrying out the planned activity as it is planned. This is very important. PM plan should be completed 100%. So we should not go out of that. This is a question of discipline. Whatever we plan, we should do it as per plan. Then inventory of spares to monthly standard output as a percentage. This is called the inventory ratio of the spares alone. We have got an inventory ratio for the entire factory. This is our own maintenance. We will have an inventory ratio for our spares compared to our standard output of the organization. Then one important thing is stock out or opportunity cost. See, when a spare is not there, then the machine will be idling until the spare comes. So then you have to make a decision whether to stock the spare or wait for the spare. How will you do? You have to calculate the opportunity cost and then make a decision on that. Then training hours to the total man hours percentage. This is how you develop your people. Give the required training in-house, outside the factory, whatever it is. So how much man hours is spent on training? Then number of continuous improvements activities per man per month. This is a very important thing, so that we make our people, all the people, think, and we have this to TOI, that is total employee involvement, TEI. So everyone should be involved, and we should get this continuous improvement activity. It will be small, it need not be very big activity. Small incremental improvements are very important. Bigger improvements will not come just like that. Incremental improvements will slowly add up to a bigger improvement. When I went to Toyota, whenever I go to Toyota, within 15 days, 20 days, I see a small improvement. So that is place where I have seen continuous improvement really being practiced very, very religiously and sincerely. Then energy consumption, unit of energy per unit of output. This is very important, especially when in the
per unit of output, 100% statutory system
of the mic,
based use.
Please switch off your mic, please. Yeah, thank you. Energy consumption per unit of energy per unit of output. This is very important because energy is becoming scarce and we have to conserve whatever energy is possible. Similarly, water consumption per unit of output. This is also very important because the energy, water and all comes under plant engineering basically. Water consumption, because water is becoming scarcity and you don't know, shortly we may have to pay a lot of money to buy water. So water consumption is very important and we should conserve water. Then one more important thing is 100% statutory compliance. Although the statutory compliance is coming under HR, the entire work is mostly done by plant engineering and maintenance. So statutory compliance is very important and 100% we have to comply with it. Then inspections, again, apart from PM, we'll have a statutory inspection, very ISO inspection, calibration, so many things will be planned and we have to religiously keep to the plan. Do it as per the schedule. And as a percentage, you should say how much 20 activities you have planned, how much you have done as per plan, 18, 20. It's better we do 20 out of 20. Then reportable accidents in the department, minor injuries in the department, all are in numbers. Near miss incidents reported in the department in numbers. These three are safety related things and how we have trained our people to work in a safe manner. And then you have the fire score and the TPM score. And lastly, the number of suggestions per man per month. This is a thing where a lot of suggestions is sought from the various people for improvements. Again, this will lead to continuous improvement. So these are the basic matrices of maintenance. It is general. Almost we used to monitor most 99% of this in Canada every month, and we used to present it to the top management this on a monthly basis when they with the executive review meeting. Okay. Now, out of these parameters, which is the parameter which is very important from our topic today, related to our topic today, OEE measurement. So MTBF, mean time between failures, is one of the most important factor which is related to OEE. What is MTBF? Time elapsed between two successive failures or breakdowns of the equipment. The time elapsed between two failures, two successive failures, is called the MTBF, mean time between failures, and it is expressed in terms of hours or minutes in time quantum. Then for monitoring purpose, we take the average MTBF, total hours available over total number of breakdowns during the period under consideration for a given equipment. See here, MTBF, it should be calculated only for an equipment. You can't average out the MTBF for 4-5 machines. You will be deceived. We'll be cheating ourselves if you do that thing. So MTBF is calculated for individual machines. MTBF and then MTTR. First MTBF is there. So this MTBF is a measure of reliability. It will tell what is the probability of a failure of this machine in a given hour. And also this tells about the qualitative work of the maintenance, qualitative aspects of the maintenance function. How well we have repaired the machine or how well we have done the preventive maintenance. So this reflects that. MTBF is a figure which will reflect. One is the probability of failure of an equipment within a given period, and then how well the maintenance fellow persons have done the work from the qualitative angle. The next important aspect which is related to the OE is MTTR, mean time to repair. This is the time elapsed from the time the equipment failed, the time when it was handed over after repair. For monetary purpose, we take the average MTTR, total repair hours of a particular machine or total number of breakdowns during the period under consideration for a given equipment. Here also, you should not average it out with all equipment. This is a measure of availability. So totally some hours is there. Out of that, so much is gone for repair time, downtime to uptime. When the machine is 100 hours, that is the MTTR. The measure of availability and the effectiveness of the maintenance function. This also gives the probability that an equipment will be put back into service within a given time. We'll see some calculations so that we understand this concept easily. So assume a number of breakdowns is in a month is 3, and the number of shifts total hours is 600 hours. The MTBF is 200 hours. 3 breakdowns over a 600 hours period. You average it out, it becomes 200 hours. So the probability of the equipment failing within 200 hours is 33%. So 400 hours, it's 66%. So failing within 600 hours is 100%. This is how we get the information, probability of failure of an equipment within a given period. So MTTR calculation, number of breakdowns, same 3 we will take. Total repair time we will take, assume as 6. Number of shifts is 3. Total available is 600. MTTR is 6 by 3 is 2 hours. So the probability of the equipment being restored within 2 hours is 33. 4 hours is 66. 6 hours is 100%. Okay. And what is availability here? Total downtime or total available 600. 6 by 600, that is 93.2% is the availability. If you want downtime percentage, it is 6.8%. 100 minus 93.2. So these are the metrics which are related to OEE, MTBF, MTTR, availability. What should be the targets for MTBF, MTTR and availability? So MTBF, the target should be, there should be 0 breakdowns between planned preventive maintenance schedules. You will have preventive maintenance schedules now in a year. You will have 15 days once or 1 month. So between preventive maintenance, you should not have a breakdown. That means in an equipment or a resource, you should have only planned shutdowns. No unplanned shutdowns should come. This is the goal. You have to work, everyone should work toward that goal. 0 breakdowns between planned preventive maintenance schedules. MTTR is 0 hours repair hours between any of, if the breakdowns are 0, then the MTTR is also 0. 0 hours between planned preventive maintenance schedules. There should not be any repair time between planned preventive maintenance schedules. Available should be 100% between planned preventive maintenance. Between 2 successive planned preventive, you should have 100% availability. So this should be our benchmark and work towards that. Now, production. So I told you in the beginning that there are 3 aspects. One is availability, which is related to maintenance. Then is the speed or the production, which is related to the production. For production, we have got a lot of matrices. Let us not worry about that. We will worry about only what is very much related to this OEE calculations. The first one is the actual output, standard output for the available time. We have seen now 600 hours is the available time as per the calculation, minus planned preventive maintenance will be the actual hours available. In that actual hours, what should be the standard output? What is the standard output? Standard output is calculated theoretically by industrial engineers by doing time and motion studies. You will tell 10 pieces per hour is the standard output for this machine. That should be used base data for you. Then you have to compare it with the actual output. If the actual output is 9, then 90% is the difference. Like that you should. That is one other thing. Actual output to the standard output of the for the given available time. The ratio is yes. This is also called speed ratio or speed. Next is setup time in minutes. See, setup is a very important aspect. See, nowadays we have varieties to be done, and the quantity in each variety is very, very less. Earlier days in 70s and 80s and all, when the machine is set up, we used to have run. 3 days it will be running in the same setup. But now it is not that case. Now you will have flexibility. When you go to Toyota, I have seen there will be 20 Corollas, 15 Innova, and then some 12 Fortuner. This will be the mix of the demand. So even the equipment will be producing in the same demand pattern. They will not produce 100 Corollas and keep it somewhere. No. Whatever is the demand is a pull system. It will demand what is the demand. It will pull through the system. Only 15 Corollas will be going at that time. 20 Innovas will be going. Only 15 Fortuners will be going. Like that it will go. At that time, what happens to make the components? Example in the presses, no, you will have the big dies. When you change the press from doing a door to do some other part, maybe the body of the car, then what happens? You have to change the die. So when the die is changed, if the die changing takes 20 hours, that is a big time. The 20 hours, all the machine is idle. It won't be useful. Production will not be coming out of the machine. So it will be waiting. That is why the setup time was huge in those days. Even when I was working in Kirloskar, we had body machining. At the time, once you set up for a frame, no, the operator will tell, I will do 50 bodies, otherwise he will not get incentive. So he will produce 50 whether he need or not. That was the case. Why? Because that setup time was huge. 3 hours, 4 hours used to set. And then after that, you used to make enough bodies so that you earn some incentive. Like that it was going on. Now, the demand is different. At that time, okay, demand was also, we used to produce, keep and sell, all those things were there. Now, what the customer wants, you are making. And that should be there. We can't afford to stock in the FG. We can't afford to stock in the work in process also. So we have to make only what the customer demand for us, from us. So setup time is very important. That is why we have got a technique called SMED in Lean, single minute exchange of dice. Although it is mentioned for dice, it is a setup time. Wherever you have got setups, try to bring it into within 10 minutes. I think you would have all seen one video of the tire changing in a race car. It will be done within some seconds, 40, 50 seconds it will be done. All people will come and they will do, and all the wheels will be changed in around 30, 40 seconds. That kind of thinking and working should be done. And this is done through SMED, will be done through some BSM studies, all those things we do, and then reduce this SM setup time to single minute. Then minor adjustment in it. See, a lot of times when the equipment is set, it will be running, then afterwards you will speed, slightly adjust the speed, slightly adjust the feed, all the spring, clamping pressure, so many minor adjustment we do. All these minor adjustment will again affect the availability and the output. Matching of the actual to standard will be disturbed. So these three, from the OEE point of view, these three are very, very important. What is target for us? Actual output. So actual output is should be equal to standard output. Why it should be less? So you have to have a target for S is equal to 1 and work towards that. Setup time, SMBD below 10 minutes. Single minute exchange of dice. Whatever setup is there, try to bring it below 10 minutes, even if it's 2 hours, 3 hours. We have seen setups brought down from 10 hours to 8 minutes, 7 minutes. It is possible because in all our activity, wastes are there. We have done BSM when we have seen what is the useful time to the wasted time. Only useful time we have seen as low as 11% and as high as 30%. 70% of our time is wasted. Wasted means we'll be moving, we'll be waiting, we'll be watching. So many wastes will be happening. If you do a waste study, it will be a relevation to you. You will see how we are wasting the time there. We'll not be knowing it. We'll be thinking we are working for 8 hours. We are working fully. No. When you do a VSM study, then you will continue. So normally what we do, we try to reduce the actual process time. Drilling is taking 1.5 minutes. Why you don't make it into 1.25 minutes like this thing? Yeah, waiting for it will be taking 30 minutes. That we will not be thinking of reducing from 30 minutes to 0 minutes. Why you should wait? The drill is by his side. So most of the previously we were thinking how to reduce the actual process time. Now the thought is how to reduce the wasted efforts, wasted time. Now the focus is so. So set. Sorry, there's an interruption. So minor adjustment is after the first piece setup. We should not do any minor adjustment. That should be a target, and we have to work for that. You're able to hear me? I am on the line. Prakash?
Yes, you are available, sir. Yeah, please go ahead.
Yes.
Yeah. Okay.
Fine.
Yeah. Example. We will see an example of this production. Standard output is 10 pieces per hour. Available time is 500 hours. Actual output is 4,650. OK pieces is 4,640. This is a small example. So we'll calculate speed. Yes is on 4,640 divided by 5,000 is equal to 0.928 or 92.8%. His actual output is 4,650. OK pieces is only 4,640. So you should take only the OK pieces, not the actual pieces produced. So 4,640 divided by 5,000, which is the standard output. 10 pieces per hour, total available time 5,000. So quality is having three components. One is rejection, regular rejection, production rejection, then production revert, then startup rejection. See, whenever a machine is set, it starts up. So, and at that time, we will have some reworks and rejects. That is a startup. When first piece is set, we sometimes lose some components while trial is going on. So that is a startup reject service. So the target for Q is in ppm, parts per million. Various industries have got different types of ppm, which, for example, if it is an automobile industry, you can see target is 0 ppm. 0 ppm. And they will have, some people will have 1000 ppm, some people have 100 ppm. So it depends on the type of industry, what kind of ppm you have got, the type you'll have. Some people will have still in percentage. So, but generally, if you work on a ppm basis, your percentages will be very, very, very less. So your target should be Q for in ppm. Example, in the last case, what we will see, out of the 4,650, 10 are rejected. So what is the accepted? 99.78 is accepted. In other words, 1.22 is the 0.012% is the rejection rate, like that. Now we will come to OEE. OEE is another matrix. Is a combined matrix for production, maintenance, and quality. This is the main matrix to ensure that you utilize your resource properly, most effectively. So three components: availability, speed, and quality or defects. Now, what is OEE? Profitability and why OEE basically. Profitability in any company is determined by the efficiency of operation. In lay terms, this means how effectively one uses one's production or resources. Overall equipment effectiveness is a key performance indicator which measures out of available time, how much time is efficiently used in producing saleable goods. This is a very important thing, saleable goods. Just because we have got a resource or a machine, we should not be producing and keeping it in stock. We should produce or we should use your resources only as per the customer demand. It should be a pull, because just because you want to increase OEE, we should not run all the machines for all the three shifts and then produce and keep it and tell our OEE is good. No. If the demand is only for one shift, please run the one shift machine for one shift. In that one shift itself, we should have a good OEE. If the demand is for two shifts, then you do run for only two shifts. If the demand is for three shifts, then you run it for three shifts, and then you can calculate OEE. So in producing, saleable goods is a very important thing. What is saleable is what the customer demands, and we can give it to the customer and convert it into money. Otherwise, what will happen? It will go to FG stores. Whatever is in the stores, sometimes may be converted into money, sometimes it will become outdated, obsolete, not wanted by the customer, and it will be scrapped. At the time, the losses will be very heavy. So people should take a very, very cautious call in a decision for overproduction, because overproduction in lean parlors is called a waste. Okay, the next one is OE is a performance metric compiled from the data and machine availability, performance efficiency, and rate of quality that is collected either manually or automatically. You can collect this with a form, people can write it, or we can have sensors and probes, etc., and automatically collect it. Nowadays, everything with IoT in machine is enabled with IoT, then all this data can be automatically collected. Not only collected, it can be analyzed, and you will get the OE, tuck, tuck, tuck. OE at 10 o'clock, OE at 11 o'clock, like that you can get the figures if you want with the current technology and other things. But only thing is, it should not be stopping at collection of data. My principle is, don't collect the data if you are not using it for improvement. Just for collecting data, you should not collect any data. Only if you are using the data for further improvement, you should collect the data. Just for knowledge, just to collect the data and keep it, no? You know, I have also collected so much data. We are monitoring this, that, that. Why you are monitoring? You are monitoring to improve. Improvement is must, and it is always possible. Improvement is always possible because we are not perfect always. There is nothing called perfection. It is only better. Better than this, better than this, better than this, better than this. So if you want to go better, then you have to improve. And for this, the data should be collected and monitored, analyzed, and then corrective actions taken. So that you should keep in mind. In most companies, bottleneck machines or key machines determine the throughput of the process. When a critical machine is inoperable, it brings downstream machines to a standstill. This can negatively affect delivery commitments to the customer, which in turn impact cash flow and revenue. For example, in a machine, suppose their feeder machine is there. It will feed 10 machines. If the feeder is done, then the 10 machines will be down. People will be idle, machines will be idle, and the customer will be waiting for the component or for the product. For example, a crane in a way. If the crane is down, all the machines will be waiting for getting the components loaded. So all the machines will be idle. So we have to categorize the machines into critical machines. These critical machines should be monitored through OEE so that they're always available and give the related output and the rated quality. What are the focus areas? Productivity metrics using OEE and losses in production with case studies. Concept of OEE. In this lecture, we will be seeing this productivity metrics, concept of OEE calculation, simulation of OEE on a machine will be shown. There is a software, small software is there. I'll show you that. And then we can collect manually or automatically. We can collect the data. And nowadays, analysis is also very, very fast and automatic. We can do that. After this program, I expect, or most of the time we have felt that the people will come to know how to calculate OEE, and not only calculating OEE, and they can find out how to improve the availability, how to improve the performance efficiency, understand how OEE can be calculated using software, understand benefits of monitoring. And I would just like to lightly touch on some waste, MUDA. Not related to this OEE, but MUDA is very important. Just one slide on that. See, there are three things with the Japanese names, Mura, Muri, and Muda. Mura is stress. Anybody who is stressed or any item which is stressed will have a strain. And in the strained condition, whatever is done, there is a very bright chances of it going as a waste. For example, an operator is there. He will have stress because of two things. One is his personal own problems when he comes for the work. We'll settle on that one. For the time being, we'll forget about that. And what are the stresses which has caused inside the working environment? For example, searching. Suppose he's searching for a tool, he gets stressed. That stress will cause a strain. And that strain, when he's doing the job, will give a higher probability of a defect. So that is why we should eliminate stress. Once you eliminate stress, strain will go off. And the strain, when it is not there, then the waste will come, rejections, defects, waste will come down a lot. We have seen this practically. We have implemented, we have studied this, and we have seen the results. So important is how to reduce the stress. We'll come to that later. OEE, how it is expressed? OEE is expressed. Hello. OEE is expressed as a percentage. OEE is equal to availability into speed into quality. Available hours. What is availability? Available hours minus planned maintenance minus breakdown hours divided by available hours as a percentage. Say 90%. Example you are taking. Output, actual output or standard output as a percentage. Say 92%. Quality, number of rejections over actual output as a percentage. 98. So OEE, when you calculate, you get 0.9 into 0.92, 0.9 is 81%. So this is how you calculate OEE. Now there are various 6 big losses which TPM does. It is very much related to OEE because these are the losses which create the availability problem, speed problem, and the quality problem. What are that? Startups, breakdowns, settings and adjustments, then idling, minor stoppages, speed losses, quality defects. What is speed losses? There is a press. The press should run at say 60 strokes per minute. But if you run at 60 strokes per minute, you won't get any quality. So you will run at 40 strokes per minute. Then you will get the compact and everything okay. We have seen so many cases like that. We compromise speed for quality, speed for running the machine, urgent production high, okay, 40 is okay, we'll manage, okay, like that we'll be doing. So that is speed losses. That is the machine is not running under the rated speed and feed, and we will be compromising in running like that. At that time, you won't get the actual output will not be equal to standard output because standard output is calculated based on our actual capable speeds and feeds for a particular machine and then calculated like that through industrial engineering techniques. Then idling and minor stoppages. If you do a lot of idling and minor stoppages, then that also will affect availability or production. Then setup and adjustment. This is what I told. SMED setup time should be as low as possible, preferably single minute. Breakdowns. With breakdowns means straight away availability is hampered. Startups. If you consume a lot of time for startups, availability is affected. Then even you will have a lot of rejections in startup. In quality and defects, of course. Rejections, reworks, all this. Now, these 6 are again broken into 16 losses based on some categories. One is manpower loss. In manpower loss, you got management, operator motion, line organization, transport, measurement, all this. What is the management? An operator comes to the machine and waits for the work order. Who is at fault? The operator is not at fault. The planner or we are not really the work order, is waiting for the work order. As I told, waiting will create first of all, waiting is a waste, and waiting will create a stress on the operator. You'll be wondering, what is that? I come in the morning, I'm not getting the job. What has happened? So stress will come and you'll be put into strain. Then later on, you may create some defects. So that is the management. You have lost waiting time for a work order, for the start the job. An operator motion. So you would have seen most of the companies will have a tool grip. where if the operator wants a drill or a turning tool, he will go to the tool grip and collect it and come. So what you will do, you will leave the machine and go to the tool. Normally, the people will not go directly to, in the between, you will be talking to 10 people. So operator movement. So he will go, and by the time he goes and get, half an hour will be elapsed. And by the time it was lunchtime, no, suppose lunch is at 1 o'clock and he comes back at 12:30, 12:30 to 1, you will never work. So these are all the things, operator movement. This will create losses. Line organization, waiting for hierarchies to clearances. Transportation, measurement. Measurement is a waste. Measurement in the sense, you inspect every piece is a waste. What they tell is, you should assure quality, not segregate between good and bad. Measurement or inspection is a technique to segregate good and bad. So you should assure the quality by assuring the correct process and ensuring that the process is followed. SOPs, follow SOPs, like that. So that is the thing. Then you have got equipment losses. You have got planned maintenance. Although it is a loss, it is not considered because planned maintenance is a must. So it is not taken into availability. Don't affect availability. Then breakdowns, it availability. Processes, startups, other downtimes, changeout times, speed, defects, and dework. These are all created by the equipment. And the energy losses. Energy, the power is required for any equipment. And wherever your energy is lost in the equipment due to so many reasons, there is a loss of energy. Then materials, yield. What is yield? For a given input of metal, you should get a certain output of the metal as per your industrial engineering calculations. If you don't get, you are not getting the 100% yield. Then overages. Overages is do unwanted things, overproduction or over operations, like that. If you do, it is a material loss. Overproduction is a classical example of material loss, because if you overproduce than what the customer demands, then those are all in your either in work in process or in the finished goods stores, which are not converted into money. As such, there are liability for you. These are the 16 losses. And this is how it is distributed towards in the OEE model. Overall equipment efficiency is equal to availability, performance rate, and quality rate. Multiplication of these things. And then availability is breakdown, setup, and adjustments. Performance rate is reduction of speed, idling, and minor stoppages. Reduce the speed and idling and minor stoppages. Then quality rate is defects and rework and startup. Whatever the rejection rework during startup will be counted in that. So these are the things. So target, you have put breakdown is 0, setup is minimized, you have a single minute. Reduce speed, you should have 0. There is not a reduction of speed, should not be there. Idling and manage should be 0. Once you set up, then after that you should not do any minor adjustments. Defect and rework should be 0, and startup should be minimized. Startup losses will be there, but we should minimize it. In waste, so many waste cannot be eliminated, but it should be reduced. Some work waste can be eliminated, so it has to be eliminated. How to reduce or eliminate these losses? We have seen 6 big losses, again distributed into 16 losses. Then we have had a model for OE calculation, and these are the various losses. OE will tell you where the loss is. How will you reduce the loss? This is where important thing is there. Once you know the losses, where it is there, how to reduce that or eliminate it, that is our next job and most important job. The lean tools are the best answer for this. 5S TPM. What does it do? It reduces minor stoppages, breakdowns, and improves speed, improves quality, eliminate or avoids searching. If you do a very good 5S, then your searching time is 0. Unwanted movements will be very less. The most important thing, you will have accidents will be reduced or eliminated. Then BSM is another lean tool. Value stream mapping. This will reduce wasteful movements, waiting, and enhances the flow. Flow of the process flow will be very much enhanced. Then SMED is another lean tool. Reduces setup time, changeover time to less than 10 minutes. Pokeyoke reduces rejections and rework. Here, The whole idea is to eliminate inspection. Suppose in the automobile industry, the vendors are only supplying. Nobody is inspecting that. If any rejection is there or any component is not okay, first time will be given, second time they'll be removed. Some other vendor will be called. So suppose there is a transport or automobile company which buys 1 million components. Think if all the 1 million has to be checked, or even sampling, if you do, it will be a huge one. So inspection is the best. So you should find out ways and means of quality assurance. So quality should be assured. That can be assured by a process, SOP, and meticulously and religiously following the SOP, and having the correct resource, which is well maintained, which will give the rated output, rated quality. With all these things, you can ensure quality, which you need not check. Output is automatic, like that will be. So these are some of the ways you can reduce the losses. How will you reduce? Most of the losses are waste. You have to eliminate the waste. Reduce the waste or eliminate the waste. With this, I can share my views. When we started these OEE studies in our factory, we started with our critical machines, and that too in one shop. We took a pilot project. We took one particular shop, product unit, we call it. And then in that, we took the critical machines. Around 15 of them were there, critical machines. And when we studied the first time we studied OEE, we found that the best OEE was around 35% and the worst was around 12%. That means we were so bad. It was like a mirror showing our ugly faces like that. Then we worked on that. Where is that? Is it availability problem, or it is the production output is not coming as per the calculations, or where we are losing heavily on rejection? Like that we analyzed, and then we worked, and then the OEE started going up. So like that, the maximum we could achieve was around 70, 72. After implementing most of these waste reduction and improvement projects. So there is one software where you can input the data, and it will automatically calculate the OEE. Just let me try. Let me go to this. You're able to see this? Hello?
Yes, sir. We can see.
Hello?
Yeah, we can see,
You're
sir.
able to see?
Yeah,
Okay. Okay.
No problem. We can
For
see.
example, I'll just make it bigger. Let me see whether it comes in the bigger one. No, in the bigger version, it doesn't come. Okay, I have to. Okay. For example, this 400 is there now. If I change it to say 500 simply for the thing, you see immediately the 71 becomes 77 here. Can you see? Are you able to see that? This 400, I made it 500. Earlier it was 71. So available hours has become 77%. Are you able to see?
Yes.
Yes, sir, we are able to see.
Yeah. So this software will be like that. You can just enter the data and it will give you the OEE, availability, performance. This is available. I can share it with Prakash and you will share it with all of you if you want it. No problem. This is actually from this thing only. It can be used. There is no need to licensing and all. You can use this one. Very simple one, but nowadays much higher versions are there. Directly from the machines, you can get this data and then calculate it. This is an old version, basically. So this is software. And this is code. Say various reasons for downtime, and they are coded for actually for data collection. This will be helpful. Maybe it's not very clear. I go to a bigger screen. So So you will have so many codes, around almost 60 codes are there. You will have code numbers are there, then particular to that, you have to give the number. And while this is only for data collection, it helps for the OE calculation data collection. And there is a manual form for OE data collection, which we used to use in Kinematel. Manually, we used to collect the data. All the data related to maintenance, production, and quality is collected. And when you collect, there may be some machines which will make 2-3 different products at the different times. Then you have to calculate the standard times for all those things differently. All those complications will come. So that you have to take care. This is a case study, one of the places where we conducted these OE studies, and we worked on that. You can see the OE calculation, it varies from 49.5%, 70%. Quality, availability, and productivity figures are calculated. They're all calculated and made in tabular column. Department wise, it is there, and the OE is calculated. So we focus on this first 49.5, how to bring it to at least minimum 60, like that you have to work. 61, you have to work how to bring it to 70. 70 is try to bring it to 80. What is this world-class OE figure? One we have mentioned is 85% is normally the, which is told as a world-class OE. If you are in 85% OE, then you are really very good. You can be a benchmark for others. So if you want to achieve, either you should have, one example I have told is you should have 100% availability, 90% actual output to standard outputs, 95% of quality. Looks easy, no? 90% and 95% quality. When you are in PPM, 95% is very, very easy. And 90% actual to standard output. So 85% is not unachievable, it is really achievable. Only thing is 100% availability should make. If you compromise on 100% to 98%, then this 90 should go to 95 like that. So you have to make a combination there, how best you can and come to 85%. And when you are doing this OE, I want to make one word of caution or this thing. Very important thing is, just to satisfy that we are getting a good figure, this OE should not be manipulated. Where all the ways it is being manipulated, I'll tell you. The standard output figures is very rarely available for all the products you produce. It may not be available. At that time, what they do is actual production itself, they will take it as a standard output. But you should be very careful in that. If you do that, then your scope for improvement will go off. You will only see bed of roses. You will not see the thorns. So you have to make the standard output figures meticulously. You have to calculate and see this machine can produce this much. And now, vice versa, we have to see what we have produced. That is one portion where. And also it is available hours also is sometimes manipulated. You should not do that one. Okay, you will not be running the machine for 3 shifts. You put the 3 shifts available and one shift only it will be running. And the breakdowns will happen in only 1 shift. When you are aggregating it for 3 shifts, again your figures will be very rosy. So that you should not do. If you run it for 1 shift, you should take available machine only for 200 hours for 1 shift. That is another thing. So like this, when you are calculating OE, you should have high level of integrity and responsibility, and you should religiously and meticulously calculate it. Why you are calculating is to improve on it, improve your availability, improve your productivity, improve your quality, so that you become world class. What will happen when you are improving like this? When you are improving like this, your costs will come down. And when your costs will come down, what you can do, you can offer a better price for the customer. Because nowadays, what is the model for pricing? Earlier days, you have produced something at a cost of X, you will add a 20% margin. So 1.2X will be the price, and that is the customer will pay. Now that is not the case. The customer is telling, I want it at 1 rupee. So if you want to have 20% profit, what you should do? You should make it in 80 paisa. So earlier, what you are doing in 1 rupee, you should make it in 80 paisa to achieve the same 20% profit. So the change has gone from buyer concept, from the seller's concept to the buyer's concept. So you have to reduce the waste. In the old model where your seller market was there, whatever the blunders you do, it will be camouflage because you are adding that percentage of profit to your cost. The cost is inclusive of all your blunders. So now it is not so. The customer is demanding the price. He is telling, I want it at this price. So you have to work out on that. That is how OE is there. OE is a wonderful tool and you have to use it very, very meticulously, and you should need not do this for all the machines. In my opinion, if you do it for your critical machines, those are bottleneck machines, because the resource will not be available to do for all the machines. So my personal feeling is we did it only for the critical machines. We did it for the very critical machines and improve that. Once you improve the critical machines, all other things, because normally your non-critical machines will not be utilized for that, will not be having the load for that much time, basically. There will be a lot of flexibility in that, where only the critical time you will have a very critical path in the critical machines. So they have to be available for most of the time and produce at the rated output and rated. So with this conclusion, the only reason to measure and analyze anything is to improve it, and so is OE. Not only for OE, anything you measure and analyze is to improve it. If you are not going to use the whole improvement cycle, there is no point in measuring it. OE is a specific measure for use in specific improvement projects. It is an improvement measure for people who want to improve their equipment performance. World-class OE is 85, so target it. Do not average OE values, it will mislead you. It is specific for specific equipment. This is very important. Sometimes people will add all the OEs of all the machines and divide by the number of machines and you'll give a rosy picture. OE cannot be averaged out. It has to be for individual machines, and then you have to improve individual machines. So with that, we'll close this. We'll have some question answers, and then because we should have some interactions on this now. So we'll have question answers. So shall I get out of the share mode and we'll have question answers?
Yes, sir, please.
Prakash?
Yeah, please go ahead, sir.
I'll go to the share. Exit share, pass share, remove. Where is this?
Whoever want to ask question can raise their hand.
The share, yeah. Stop share, yeah. Okay, now we'll have, yeah.
Please introduce yourself, sir, and your organization. Please go ahead with your question.
Yeah. Sorry,
Sir,
I am unable to come in the video because this laptop is. Yes, sir. Tell me, sir.
Sir, I am Palnivel, Additional General Manager, BHL, Maintenance Service Department. But I don't have a question, but I am very happy to receive all these details because we already implemented during 2006. We already implemented OEE, not in bigger way. But now the improvement is going on. Now our achievement is 56.39 for August month. We have taken, because thousands of machines are there, we have taken only critical machines up to 15, 45 to 55 machines, and we are doing it regularly. Of course, there are very, very old machines available, which is critical in nature. That's why the lagging of a percentage in that operation. Otherwise, we are maintaining it. However, I got a few more points from Mr. Shekhar, which is helpful to us. And my people are also, my people here, the committee members these people are also very much appreciated for this data, for getting things done. We are also implementing now IIoT, Internet of Things, for few machines, 1 or 2 machines. I hope we will be successful.
Hello.
Thank you, sir. Go ahead, please, sir. Go ahead, please.
Hello.
Sir, Palnivel.
Good.
Right, sir. Thank you, sir.
Yeah, tell me.
And any other person want to share his views? Participants, you can go with questions.
No, sir. No. I just informed Mr. Shekhar that we already 2006 we this implemented this, and additional information what you have given is useful to me. That's why.
Okay, sir. Thank you so much. So
Good.
Rajgopal want to
Good
ask.
that you are in 56%. Try and next higher percentages.
Sir, 56 with a great effort, we have done it.
Good, good. No, 56 is also very good. When we started, we have seen figures of 19 and 18 and all.
Yeah, sir. We starting only came
Rajgopal.
only 45, right.
So Rajagopal, Mr. V.S. Rajagopal wants to ask question, sir. Mr. Rajagopal,
Yes, sir.
camera if possible.
Yes, sir. Good evening, sir. Shekhar, sir, thank you for your presentation. It's very good.
Yeah.
Now, are you able to hear, sir?
Yeah.
Hello?
Yeah, I'm able to hear, Rajagopal. Tell me. I'm able
Yes,
to
sir.
hear.
So my
No
question,
problem.
my question, sir.
Please.
Because of custom, hello?
Sir, can you switch on
Yeah.
your video also so that we can see you?
Yeah, you can switch on the video, Rajagopal, so that you can see your face. No problem. Yeah. Switch on your video. No problem.
All.
Yeah,
Participants can, now lecture is over, you can switch on.
So everyone can see you, Rajagopal.
Yes, sir. Actually, I'm in the mobile, sir. Unable to switch on. Anyhow, not a problem. I'll come back once again. Sir, my question, sir. Hello? My question. Because of customer demand, okay, instead of 3 shift, we are running only 1 shift.
Okay.
Okay, in that case, so I am producing 100% output. So there is no breakdown. Okay, and what do you call, all the 3 parameters I met. In that case, how to consider availability, sir? Because customer demand is not there. I bound to use only 8 hours. So if I produce all the parts, good parts, all quality parts, no, then can I consider OE as what do you call 95% or 90%? Because there is no breakdown.
I'll tell you.
So I want to understand what is the availability, sir. That's all.
Availability is your availability hours is 1 shift, 8 into 25.
Yes, sir.
How much is that? 200
yes,
hours.
sir.
Out of the 200 hours, what is planned maintenance? You remove it. Then you will get a figure
yes, sir.
160 or 180. In that, what is
Yes,
your
sir.
breakdown time? What is your minor adjustment setup? All those things you have to reduce. Then only you will get the actual available time. In that actual available time, how much you are producing and what you should have produced. Suppose you get 140 hours your actual time, available time.
Yes,
In
sir.
that 140
Yes, sir.
hours, how much you should have produced as per your standard calculations. That is
Yes,
to
sir.
compare and put it in the performance rate, performance or speed. Of
Okay.
course, quality is actual production pieces minus your rejections. That is your quality rate you will get.
Yes, sir.
For availability,
Okay.
it will take only 1 shift hours, not 3
Yeah,
shift.
even though the 2 shift loss for me, correct, no? Is a management loss, so because customer demand is not there. At least whatever I run the machine, no, in the 1 shift, for particular day, particular month only, I can consider same, correct, no? 1 shift only. That's why my questions.
If the demand is more and if you are running for 2 shifts, consider 2 shifts. That's all.
Yeah. So to make it dynamic, correct, no?
Yeah. You can make a
Yes,
dynamic correction. Availability hours you can always change because on the demand.
Yes, sir. Yes, sir.
See, just because you have got a resource, you cannot use it. See,
Yes, sir.
whenever your requirement is there, even if it is a 1 shift requirement, you buy a machine. Although the machine is available for 24 hours. No.
Yes, sir. Yes, sir.
Most of the machine you will be using for only 1 shift only.
Okay, sir.
Then now we will take only 1 shift as the available hours. Yeah. And the related output in 1 shift, related quality in that particular shift. And for a particular machine, OE is always calculated for a particular machine and then improve that machine. Never average it.
Okay.
Yeah.
Yes, sir. Okay.
Yeah.
Thank you, sir. Thank you.
Thank you, Rajgopal. Yeah. Anybody else?
Speaker,
Yeah.
Speakerji, I'm Sitaram here.
Yes, sir. Tell me, sir.
It was wonderful, enjoyable. Actually, so much of information. I think you see, we are framing the outline for the circular economy. So this happens to be one beautiful method of analysis. I think Ashokji also will agree, and also all my other friends. So I think we'll stay in touch. In the digitization, digital transformation, I think 2021 The 2020 we toiled hard. We couldn't make much progress. 2021, I think we'll go ahead.
Yes,
I
sir.
think we'll take all good ideas from you.
Dr. Sitaramuji, you can come in camera. Possible?
Yes, yes, sir. Yes.
We are not able to see it.
No, all people can switch on their cameras when they come on question. They will be.
Please put the camera for everybody.
Yeah.
Oh, yeah. So nice, Shekharji, Prakash, and all my friends. I think 2021, I think should be. I think we'll go ahead at high speed on all our goals.
So you
I
should
think this
have the
is a-
rated output.
Yeah. Yes. We have stored the energy like capacitors. I think we have to release. So I think something good is going to happen. So maybe from March, April onwards, I think it'll be really good. So it was a wonderful deliberation, Shekharji. Thank you. Thank you so much.
Thank you, sir. Thank you.
Any other questions, sir?
Hello, Shekhar, so one more question.
Now,
Rajgopal here.
tell me. Rajgopal.
Sir,
Yeah.
regarding MTTR targets,
Hmm.
mean time to repair target.
Hmm.
Hello.
Yeah, tell
Okay.
me.
So
MTBF,
suppose
no?
previous
Mean
months
time
there is
between
no
failure.
breakdown.
Hmm.
MTTS to repair.
MTTR, mean time to repair.
Yes,
Yeah.
sir.
Yeah.
TR.
Yeah.
Yes, sir.
Hmm.
Yes, sir. See, earlier cases there is no breakdowns. Okay.
Hmm. Hmm.
So and the target was 0. Okay.
Correct.
But next month now it will break down for 8 hours. Okay. Next consecutive month it will break down for 2 hours. Example, no. So if I put target as 0, okay. Sometime for the particular month where I have not achieved, no, I should have an action plan. Okay.
No, actually.
So my question, whether we need to consider all PFM, all the possible causes for machine breakdown. Example, heater failure, then pump failure, some hydraulic problem, some hose problem, some like that. No, if you capture, no, what the possible time, repair time, if you calculate, if you put average time as a MTTR, then it may be what you call scientific to set the target. So otherwise, if we put 0 as a target, we never achieve the 0. Correct? No. So that's my question, sir. So how to set the MTTR target? So that's my question, sir.
I'll tell you, Rajgopal.
Am I clear, sir?
During my presentation, I told
Yes, sir.
MTTR should be 0 between planned maintenance. That is very important. See, you will have in a machine, you will have two
Yes,
planned
sir.
maintenance. If the planned maintenance are separated out by a month,
Yes.
you have got one planned maintenance today and after another planned maintenance next month. Between these two planned maintenance, you should not have a breakdown. That is the principle. MTBF should be 0. Once MTBF is 0, MTTR will be automatically 0. What you told is, if you have a breakdown, then you are analyzing the breakdown. What is the reason? Whether it is electrical problem or a mechanical problem, hydraulic problem, whether in the hydraulic problem there is a pump problem or a valve problem or a filter problem. That is subsequent analysis when a breakdown analysis. For targeting MTTR should be 0 between planned maintenance. That means once you do a preventive maintenance and hand over the machine, the production person should not bother about the availability of the machine till the next planned one. What is planned maintenance? Known breakdown. You are planned for the shutdown of the machine. So the production fellow will know. Yes, today second, third is planned shutdown. Next month, third, fourth is the planned shutdown. So he can plan his production. Ambiguity will be less. That is why we tell MTBF and MTTR, there should not be any breakdowns between planned shutdowns. If you take our Maruti car, when you are going to service once in 6 months, in my experience, between that 6 months, it has never failed. Unless we have gone and hit or something like that, due to accidents or malfunctioning, maloperations like that. Otherwise, I have seen when you are meticulously servicing it, you will never have a breakdown between services. Same concept should be adopted. Maybe, I don't know, because of some power fluctuation, it may happen, some electronic problem may come, that is all. Okay, they're all some stray cases. But MTTR and MTBF should be 0 between planned maintenance. You work towards the target, you will really achieve, and nothing is easy, nothing will come in a platter. You have to work for it.
Yes, I agree.
See, in our Kenametal, we had one target, 0 breakdown days for the entire factory.
Oh, yes.
See, there are 8 factory units, P units, and to achieve zero breakdown days in all the 8 is very, very difficult. If one machine down in one shop also, that figure is gone. What is the best we achieved? No, 18 days zero breakdown we achieved when I was in service. 18 days we had zero breakdowns in all the 8 PUs. That was really, we didn't achieve 30 days or 6 months. No, 18 days, that itself was very commendable because 18 days, there is no breakdown in any shops. So that is the kind of thing. So you work with zero, see nothing, see we have to work towards stringent targets.
Yes.
Achievable target, if you work now, there won't be thrill.
Yes, sir. Agree.
Achieve towards zero. I will be fully agreeable with you that zero may not be possible in so many times. But still, if you work towards zero, you will achieve very, very good results.
Yes, sir. Agree.
Yes.
Thank you.
Shekharji, I'm just reminded of one particular incident, actually partly later in. One American company ordered so many parts in a Japanese company. They put a specification like 1 in 1,000 defective parts. And it so happened, Japanese people supplied 1,000 parts plus one defective part also. They asked, why do you want one defective part? This is a defective part, we are giving you, take it.
The specification, to meet the specification.
Yes, just to meet the specification. I think this must be a joke only, but Japanese really work like that.
No, they work. They work in PPMs. See, always in life, you have to take a stringent target and work towards that. Taking a very lighter target will not really push us to the 100% limit.
Yeah.
Any other participant want to ask question?
Shekhar sir, overall equipment effectiveness, your overall presentation is totally excellent, highly informative, pinpointed to the practical culture, practical way of doing the practices, the technical awareness and the management initiative. Everything you have combined together, and it's an excellent practical lecture on this OEE. It is very much useful to us. Thank you, sir.
Thank you, Mr. Ashok. Thank you. Any question?
Kalinath here.
Yeah, yes, Mr. Kalinath. How are you?
Yeah, fine.
Yeah.
I wanted to ensure that in your newsletter, in your coming newsletter, the gist of this particular presentation should be briefly presented so that those who are not able to participate can also understand and make the use of the information. It's very, very well defined.
Yeah. Sir, this will come in our YouTube. It will be available in
YouTube is fine, but I am telling you about our
pen.
In-house magazine is there, no?
Yeah. Correct.
In that in-house magazine, you please put it because that will become a permanent record with the people.
Yeah. I'll request Prakash to do. He is editor of our pen. I'll request Prakash to do the required.
A pen person who is managing the pen should be able to take the briefings and put it in the magazine. Thank you.
Thank you, Mr. Kalyan. Anybody from Tegutech? They're attending. Any questions? Able to attend?
Yeah, Mr. Rajagopal already from Toyota.
Rajagopal is from Toyota, TG Sen.
Yes.
From
Tegutech,
a lot of people attended.
And other companies, I think.
There's Senapati Whiteley is there. I didn't have here any.
Saravanan, you can give your views because you are also using OE, I think. Dr. Saravanan, please. I think he's traveling.
Yeah. Senapati Whiteley team is there?
Dr. Saravanan?
Yeah, speaking, sir.
Yeah.
Dr. Saravanan, you want to give your views on this OE? Please, go ahead.
Sir, I couldn't get you, sir. Hello?
Yeah, you are working with OE. You can give your views, sir, on this subject, on the OE measurement area.
Okay, so I am Dr. Saravanan here from Caterpillar, and I think this is one of the best sessions I have ever heard from the IIA forum. So I've been associated for more than 3 or 4 years. And definitely this is one of the useful sessions. And in our factory too, for our machine shop, this is one of the criteria of measuring the OEE for all the machines. We have close to 70 plus machines in our machine shops, which is, as you know, it is very, very difficult to understand the effectiveness and monitor effectively. And one thing what we have introduced now is we're putting into the digital technology for that in measuring the OEE and monitoring the machine right from the manager's cabin. So we are also putting that technology into that capability of measuring the OEEs and getting it here, getting it onto the management desk. So this is one good thing that really happens here. And apart from that, the inputs that what Shekhar sir has given are really, really very useful and very, very insightful. I think two of my colleagues are also participating in this, and they have also got benefited from this. So thank you, Shekhar sir, and looking forward for many more such sessions. Thank you.
Thank you, Sharadan. Thank you.
Hello.
Ah.
Yeah, sir. Shekhar sir, this is Balon Singh here from Tegu Tech.
Yes, sir. Tell me.
Yeah, sir. It was very nice session, sir. We had taken a lot of inputs from you, and it was a good session overall. And for your kind information, sir, we have started, as you said, the software which is implemented in our factory now.
Very good. Very good.
Yeah, sir. It is called as the Lean Works. Yeah,
Correct.
it is connected to the clamping devices and all those things. And we are getting on daily basis the reports through software only. And wherever the losses are there, we are discussing on daily basis, and we are triggering, sir. Actually, we are at 68 to 72% now overall on the critical machines only. Yes, sir.
Yeah.
Yes, sir. Nice to hear you. Sir. Nice to hear this, sir, from your side. And it was overall good session.
Yeah.
Thank you. Thank you so much.
Thank you.
Thank
you, Mr. Bell. Yeah.
Yes. Thanks.
Any other participant?
Sir, what I understand.
Mr. Kalina? Yeah.
What I understand is number of participants are very limited. I think due publicity is not given to the our IIPE members. Otherwise, it should have been at least more than 150 people. Anyhow, next time, please ensure more participants are getting benefited.
In this connection, I would like to tell you a thing.
We will end this program.
We have got 8 chapters all around the country.
Shekhar sir, we will end this program in the YouTube. Then we will come on live, please. I will end the program in the YouTube.